Scala is an important programming language with huge amount of influence on big data analytic tools like Spark. The reason behind such importance is the power of functions and the basis of functional programming inherited in this language. In Scala, every piece of problem is recommended to be solved by functions, as function calls are expressions and they will be lazily evaluated. Lazy evaluation is one of the fundamentals of the Spark Big Data Programming model. In this tutorial, I would like to demonstrate functions, anonymous functions, map and filter functions with examples. So let's get started. Okay, let me create a new project. File, project. Of course, you can proceed with your ID of your choice. Here I use IntelliJ. I would like to create a new project. So I select the Scala idea and then click next. I would like to name it anonymous functions and click finish. Open it in a new window. I click on the source, create a new Scala class, and I select an object and I name it anonymous function func. I extend app that we are able to run this class. For defining function in Scala, we can use the def keyword. So for example, I can write def pow function, and I can define the type of the input variable, like for example the input to be double and the output to be double also. And for example, this function does the power, and or for example, if I want to define another function, I can use the def keyword again, custom function, and this function can receive two variables instead of one, again both of them to be double and the output variable to be double as well. And here I'm using just 2x plus y. I want to calculate the summation of x plus y. I could write return here, but there is no need because in a Scala the last statement of the function is its return value, and calling of a function is an expression. So if I want to call this two function, I can write pow function, I can give here 5 for example, and the custom function I can say 5 and 10. I write println and println here, and I run the function and it should print the output on the screen. Here we have 10 and 24. 5 multiplied by 2 is 10, and I can name this custom function 1, and this custom function 1, and I name this custom function 2 here. So I would like to change the function. Now I would like to explain the anonymous functions. For defining an anonymous function, I just use the val keyword here, like for example custom anonymous, and instead of using the def keyword, I can use the val keyword here, and I need to define the types. So for example, this function will receive an input of double and generate an output of double, and the definition would be like it wants to receive an x and just double this x value. So this custom anonymous is equal to the custom func 1. I can write custom anonymous 2, and it's possible to ignore this double to double. I can ignore this type. However, I need to introduce the type here. Like I should say double to x of double to x multiplied by 2, and both of them should generate the same result. So I'm writing here println result of custom anonymous 1. And also here I'm writing custom anonymous. Here this is the function. I would like to call it with the value of 5 again. Here it is println, and as well as here I write println result of custom anonymous 2, and here I am writing like custom anonymous 2 with the value of 5 again. So let's see, here I'm missing parentheses. So let's see the result of this, and I just save it. I run it again, and you can see that both of these anonymous functions generate the value of 10, which were equal to the first function here. The anonymous function, instead of the def keyword, we can use a val keyword, and basically we are defining a variable, and this variable holds the definition of the function. We can specify the input type and the output type of the function, and basically we use this arrow to say that, okay, this input is processed to be generated this sort of output. We can remove the definition of double to double, and we can add it to the definition of the function, meaning that we can specify it here. But I want to show you another version. So if I write custom anonymous 3, if I just copy this and I say custom anonymous 3, and I remove that double here, and I just write x multiplied by 2, then the function should not be able to infer the type, and that's why here there is a red. It's red because it cannot infer the type. We can also define anonymous functions with 2 input variables, like for example anonymous functions. So for example, I would say custom anonymous 3, then I can say that it receives double and double, and it generates a double, and the definition is like it gets x and y and produces x plus y. And this is exactly the same as this function here, which we defined, in which it receives 2 double and generates an output of double. Yeah, this is the anonymous function because here we define the variable, and then here the type, like it receives 2 input and generate an output, and here comes the function definition in which it basically receives an x and y, and basically the output would be x plus y. So if I run this function, so for example, if I write custom anonymous 3, here I can say 5 and 10, 5 and 19, for example. Then I can run the function. You can see that we have 24, which is equal to the first function here. So this anonymous function definition is exactly equal to this custom function too. I hope you have enjoyed this video so far. If you have not yet subscribed to this channel, please do so. Thank you very much for your attention, and see you next time.